got a couple of different ways we can solve something like this. And so we're just kind of looking at question 10 here. It says, without a calculator, estimate. Well, to start, I know that 2 to the exponent 2 is 4. 2 to the exponent 3 is 8. So 2 to the exponent something in between is what I'm looking for. And of course, good old-fashioned calculator, I can do something like this and just try 2 to the exponent 5, see where I end up. 5.6 is too high. Okay, so how about 2 to the exponent 2.3? 2.2, let's try. 4.6, so too low. So go a little bit in between here. 2 to the exponent 2.35. Oh, that's not too bad. 2 to the exponent 2.3 exactly. Ooh, a little bit low. And sort of narrowing it down here to the exponent 2.33. And we're getting closer and closer. So that is one option. A little bit nicer option probably is to use a graphing calculator, or in this case, again, the Desmos graphing calculator. The suggestion here is if you graph the two different equations, this as one equation and this as one equation, then you can find the point of intersection. That works very well if the two equations are a little bit more complicated. When you just have a number on the one side, then what we'll do is we'll just graph the one equation and kind of scroll along it until we find the answer we're looking for. So in Desmos here, I can graph y equals 2, and then down here, my exponent button, 2 to the x. If you leave out the y equals, by default, it just understands that that's what we're doing as well. Now off to the right here, I'm going to set the graph settings to projector mode just because I get a little bit easier graph to see. And then if I click and drag, I can do sort of very reasonable things here. Click on the grid and move it around as I want to, or I can scroll up and down with my mouse button and zoom in, zoom out. I can also, under settings, change the x-axis, change the y-axis. So if I decide there seems to be no negative numbers, seems to be no negative numbers on the y-axis, so maybe I'll only have it go down to 0. And if I want to zoom this in, zoom it into 6, and so there's another option for me. So what I'm looking for now is, where does the value equal the number 5? Yes, 2 to the x equals 5. And so essentially I'm looking for the y value of 5. Well, clearly here, my line's already there. If I click on the graph, I can see this is a point on the graph, and I'm basically just going to get it as close to a y value of 5 as I can. So there's 2.32, there's 2.32, I can't really get any closer than that. So 2.32 looks like a pretty good answer. 2.325 is a pretty good answer as well, and I've kind of narrowed it down fairly quickly that way. Again, the calculator method obviously is fine, but this is a little bit nicer. If I did have something a little bit messier, 2 to the exponent x equals, let's say, 3 to the exponent x, or say 0.5x minus 4. Whoops. Not what I meant to do. 0.5x minus 4. The two graphs are drawn, and I can kind of zoom in to determine if and when the two graphs cross. Now it does look like they probably don't. So something else here, change that value. I can see there is an intersection point here, and I can determine it quite accurately, quite quickly. Okay, so again, with two equations that are a little bit more complicated, I'm looking to graph them and find that point of intersection. Maybe just something simple like x minus 5 even. Oh, that's not going to work. So something simple like x plus 5, and we can see sort of where the various solutions are. In this case, there are 2. And again, just using the graphing calculator, to find equations. So this would be if the question said 2 to the x equals x plus 5, and we didn't know how to solve that, what could we do? Well, again, here's a possible solution.